Good morning, children. Today we are going to start with algebra. I think on WhatsApp I've already completed till chapter 8, speed, distance and time. I've given all the explanation, I've given videos and all. So go through it, say it a couple of times, you'll get it. It's not so difficult. And speed, distance and time, you do it in physics also. So it should be just a repetition, in fact a revision for you. If I've done it earlier than physics, then when you do it in physics, it's a revision. If I've done it after physics, after it has been covered in physics, then it's a revision for you. So today we're going to start with Algebraic Expressions, chapter number 9, page 150. Okay, now what is algebra? Algebra, again, let's go to the book also. When the book has been prescribed, we'll have to use that also. It says out here, what are algebraic expressions? They are expressions that represent mathematical ideas and operations in a short way using symbols and variables. Okay, words are coming up. I'll explain later on. And how are these expressions formed? It says constants, which are numbers, variables and operation symbols are combined to form mathematical expressions. And the book itself says, and this question should have already popped in your mind by now, it says, what are constants and variables? Okay, now, what is algebra? Algebra is a mixture of numbers, alphabets, a combination of numbers and alphabets, or just a number or just an alphabet. And the operations that are involved is plus, minus, multiply and divide, the four operations of maths. Okay, so what are constants? A constant is a symbol in algebra which has a, okay, this is by the book, a constant in algebra which has a fixed value, that is whose value doesn't change, is called a constant. Okay, basically what is a constant? A constant is a, in simple words, it's just numbers. Okay, yeah, simple numbers like 7, 9, 2, 6. These are all constants. Okay, now we come to variables. What is a variable? See, constant from the word, it's a constant means something that doesn't change, something that is fixed, constant. Okay, that is the meaning. If we go by the English dictionary, the English meaning of constant is that, right? So it doesn't change, so number doesn't change, the value of this will not change. What is a variable? A variable, according to the book, says a symbol which can be assigned different numerical values is called a variable. In algebra, the variables are denoted by letters in English alphabets like A, B, C, famous for maths, X, Y, Z. These are variables. That's what's given in the book. But sometimes a combination of a number, a combination of a constant and a variable, or number and a variable is also a variable, because this is 2 of A, 6 of XY. It's just saying how many. If you just put A, that means 1A. If you just put XY, it's 1XY. This is saying 6XY. So this whole expression, though there's a constant out here, this also becomes a variable. That's not given in the book. Understood? Okay. Now, so what is a constant? A number. Just remember, in algebra, constant is numbers. Variables is alphabets. Understood? And sometimes a combination of an alphabet and a number is called a variable. Right? Now, what is an algebraic expression? The topic itself in the book. Okay, let's give you, let's say, okay, the examples given in the book is 2x, comma 3a upon 5. I mean, you can take any example. I'm just following the book example so that you can relate when you go through the video. X minus y, p plus q, understood, etc. Now all algebraic expressions. Okay, the third one is nice one. 2a square minus 3ab plus b square. Understood? Okay. So this is an algebraic expression. Can you see? There is a variable, Okay, you can add one more thing. Okay, let's say plus 7. Okay, variable, variable, constant. Okay, separated by operations plus, plus, minus. So this forms an algebraic expression. Understood? Okay, now uh, it says out here that a to the power 5 is nothing but 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. A to the power 5. It just means that. So it can be expressed as a to the power 5. Okay. So variables can also be written in exponential form in the manner similar to constants, like this way. It's an exponential. Exponential means power to the power. We've already covered this in the earlier chapters. Okay. So in this case now, what are terms? What are terms? These are the terms. Now, what separates terms? Okay, we have 4 operations in maths. I'm going to write this thing again, the algebraic expression. 2a square minus 3ab plus b square. Okay, I think I had done plus 7 that time. Okay, so these are terms. All these are terms. Excuse me. Okay, all these are terms. Okay, now I don't think so. In the book it says a term is an arithmetic number letter, group of letters. You can add one more. ABC. Group of letters. A group composed of arithmetic number and letters. As I told you, these are also variables. Are all terms. Okay. Now, what separates terms? We have 4 operators: addition, subtraction, multiplication, division. Please pay clear attention out here, because this is the basic of algebra, the starting. You must have encountered this in class 6. I don't know how far you went, right? But right now I'm telling you the most of the things that you need to know about algebra. From here onwards, this is just you identifying them. Then we'll do a few operations in higher classes like 8, 9, 10 and all. It's going to get vast. They're going to be huge number of terms, big numbers, and involve big operations, involve confusion. So right now, if you understand these basics, it's like the ABCD of algebra. It becomes easier for you. Now, among the 4 operators, addition, subtraction, multiplication, and division, what separates terms? It's only these 2. Okay, this and this, multiplication and division, is invalid. Only addition and subtraction separates terms in algebra. Okay, now let me just create a new expression. Okay, so let's say 2a square into 3bc plus 3ab divided by 2ca plus b square plus 7 into 7 plus abc into 6xy. How many terms? Okay, I would love it if we were having a real class inside a classroom, children. Then I can interact with you. It becomes better, but that's devoid this year due to pandemic. Yeah, but still, I'm trying to make it, because when questions are asked, it's nice. It becomes like a dialogue, right? So you put up your questions, I can answer that, clearing your doubts and all. But since we are online, you're just going to see my video. You can always get in touch with me if there's any clarification that needs to be done. But I'll try to make it as clear as possible right now. Okay, now look at this. By looking at it from a layman's term, if I ask you how many terms are there, those who are just getting introduced to algebra, not so sure about algebra, you'll say 1, 2, 3, 4, 5, 6, 7, 8 terms. Sir, 8 terms. Sorry, wrong. Cannot be. As I told you, only addition and subtraction, they separate terms. Multiplication and division does not matter. So actually, how many terms do we have? These two, though it looks like two terms, but there's a multiplication thing in between. Sorry, term 1. These two, again, division in middle. So this is counted as 2 terms. Term 2, term 3, the fourth term, or term 4. Why? Why? Because of the operation. Addition, 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 or out here in this, if there seems to be too many additions, we'll put a subtraction out here. Subtraction. Okay, let me put one more subtraction out here so that it becomes clearer for you. Okay, so that's the way it is. Children, get it very clear, very simple. It's very simple. Only addition and subtraction, the operation, the symbols, separates terms. Because why terms are important in algebra? Because after that you'll have to compute. After that you'll have to compute, come to a solution. If you cannot come to a solution, you'll have to leave it like that. But most of the mathematical problems, I don't think so. The question itself is the answer. The question is given so that you can compute and come to a solution, right? Sometimes you come to a single term, sometimes there might be 2 or 3 terms involved. That's later on. Understood? So get these things very clearly right now. Okay, now if you move on to page number 151, page number 151 on your textbook, there is an expression given. Okay, I like the way they have done in the book. Okay, the expression is 3x squared minus 4xy plus 7y squared. Okay, now the book says, what are the terms? What are the terms? These are the terms. This is a term, term 1, term 2, term 3. Why? Because of the operators. One is minus, one is plus. Okay, now what are the factors? Okay, so if you go to the book, a term is a part of an expression connected to other parts of the expression by a plus or a minus sign, as I've told you, by a plus or a minus sign. Thus, 3x squared, 4xy, 7y squared are all terms of the given expression. Each term is further made up of factors. What are factors? Each term. Now look at the terms. Look at this term. How many things are there inside? Let's not talk about units and all. Let's not use the word factor right now. Just see how many things are there, countable things. 1, 2, 1, 2, 3, 1, 2. Right? So what constitutes a term? What makes up a term? It's the factors that makes up a term. Understood? So these are the factors. So if you look into the book, the factors, the things that make up a term is 3x squared, right? X squared means what? It's just been written in exponential form. See, what would you prefer to write? 3 into x or 3x squared? Which one would be easier for you, technically speaking? This? When you just write this 3x and x, if it's just this much, then it's okay. But what if it's a huge expression like this, and let's say this was x4, y6? It becomes confusing. You can't keep writing again and in maths, the longer it becomes. See, maths is all about comprising, compressing, trying to bring, it's like huge thing is there. You break it down, try to make it, even if you see the sums in your book also, no? There'll be a huge, then you start computing steps by step. You see most of the maths solutions, sums, they become shorter. And in the end, you either come to, if it's pure simple arithmetic, you come to a single number or a pair of numbers. In algebra, either 1 term, 2 terms, 3. It's just simplifying. Maths is all about simplifying, coming to a solution, bringing an answer, right? So the factors out here is each 3x squared means 3 into, so it is 3x and x. So what is the factor out here? This is 4x and y. Here is 7 and there are two y's, that means y and y. Or y into y. Understood? It's very beautifully broken down. Expression. What expression? I'll write it further. Algebraic expression. This is the algebraic. 3x squared minus 4xy plus 7y squared. What are the terms? 3x squared, 4xy, 7y. Why? Because there is a minus sign and a plus sign. As I've already told you, a minus sign and a plus sign are the only two operators that separates terms. Okay. What are the factors? Factors. What is a factor? In a term, who all are there? Who all are involved? What are the things in a factor? What are the things in a term? Look at the first term. There's 3 and there's x squared. That means there are 2 of x's. So these are the factors of this term. 4xy term. What are the factors? Who are the members? Who are there in this term? 4 is there, x is there, y is there. So 4x and y are the factors. Understood? 7y squared. That means 7 into y into y. Please get this very clear because later on we'll be doing degree. We'll be doing coefficient, we'll be doing like terms, unlike terms. These things are important because whole algebra moves around this, circles around this, and if it's not clear, it becomes different. Okay, difficult, I'm sorry. Now, the next topic that we have is coefficients. What is a coefficient? Just go by the book again. In a term, the number factor of a product is the numerical coefficient, number factor of a product. This is a product, multiplication, 3 into x, product means multiplication, right? Is the numerical coefficient of the remaining factors. For example, in 27x squared, okay, I'm just using the examples from the book so that you can relate. You can give my own, you can use your own. In 27x squared, the numerical coefficient of x squared is the numerical. What is numerical? Numerical means number. The numerical coefficient of x squared, or basically in simple terms, English terms, I don't know why we use big words. Who is there with x squared? Obviously, any layman can answer that. 27 is there with x squared, right? In this term, who accompanies x squared? Who is there with x squared? It's 27. Understood? You can say it anyway, but if you use the word coefficient, what is the numerical coefficient in this term? It will be 27. Where the numerical coefficient is not given, it is always understood to be 1. Okay, so let's say, as I've already told you, if you just write xy. So what is the numerical? Obviously, it's understood. It's 1xy. Even if you write a, what is the numerical? It's 1a. But it's understood. That's why we do not write the numbers. Okay, this is very important again. When the numerical coefficient is not given, it is always understood to be 1. The numerical coefficient of xi is 1. The numerical coefficient of, let's see, now this is again this is one thing children get confused. Over my years of experience of teaching math, I've seen there's this little confusion. What is the numerical quotient minus? Sir, there is no number, there's only minus. No. If there is a variable, okay, if no numerical coefficient is there with it, or there is no number with a variable, it is understood that it is 1. So what is the numerical coefficient of a? If you leave aside, it is understood. We do not write. Like whenever we write numbers also, we just write 27, right? But it is understood this is 27 upon 1. Or if you just write 26, it's 1. Let's say it's 1075. We just write, but it is understood. But for convenience sake, we do not write these things, okay? Everything is in a fraction format, actually speaking, right? I've already covered this in the previous chapters, right? So out here also, it is understood when you only write the alphabet, you have to presume it is big. That's the rule. That's the way it is. A itself. How many A's are there? 1 A. How many C's are there? 1 C. How many X's are there? 1 X. But what is the value? minus. Okay, so what is the numerical? So in the book is also given the numerical coefficient of minus p is 1. So if it is minus a, it will be minus 1. This will also be minus 1. This will also be minus 1. Okay, so basic question is with a, what is the number that is minus, minus, minus? Understood? That's the way it is. Okay, get this very clearly, children. You can go through the video again and again. Okay. The letter factor variable or product is the literal coefficient. For example, in 4x, the literal coefficient is x. Okay, so let me go through that table again. What is literal? What is literal means alphabets. Okay, so 45 a square b. What is the numerical coefficient? Numerical coefficient, literal. Okay, what is the numerical coefficient? All of you should be, by now you should be able to do it. 45, isn't it? What is the literal? What are the alphabets there? A square b. Next example, minus 7xy. What is the numerical coefficient? Minus 7, right? What is the alphabet? Literal xy. Okay, children, get this straight. It's very simple. Okay, don't try to get confused. Go through this video properly. Okay, now we come to terms now. Like terms, unlike terms. By the word itself, what do you understand? Like. Like means similar. Like terms. Like means same. Not different, same. Okay. For example, if you go in the book, 5a, 3a, 7a, 7a, let's say 27a, 1064a, any number with the alphabet a. See, don't get confused again with the constant of the numerical coefficient. Okay, it can be anything. Okay, but what you need to consider, because this is a variable now, this is not a constant. If only a number was there, then it would be a constant. Now this is a variable. So once it turns into a variable, this, as I've already told you, what is this? This is 5 of a's, 3's of a's, 7 a's, like that, 1064 a's. Understood? This number is just this numerical number that you see, just notifying how many variables are there, right? So all of them are like terms because of this. Okay, let's say I put 2c, 6y. Would it be like term? No. Numerical coefficient is there? Yes, there. Alphabet, the variable, the alphabet that extrudes and extrudes. Is it same? C? No. Y? No. So sorry, these are not like terms. Understood? So like terms means, see, it might be simple. Some later on in when you start computing, you might have 7abc. Okay, one important thing, because I don't think there are many things in this book which they do not cover. Okay, 7abc, let's say 6abc, okay, 8bca, 10cab. Okay, now if I put up a question, are all of these like terms? Many of you will say no. 99.9% of you will say no. Why? Sir, ABC is there, ABC, sir, this BCA, CAB. Sorry, you're wrong. It will be totally wrong. It's algebra, it's maths. As I've told you, concentrate on the numerical coefficient and the literal. 7abc, 6abc. Looks the same, yes. Number is there, there. A is there, there. ABC, ABC. See. But these two are also same. Why? A is there, A is there. B is there, B is there. C is there, C is there. It's just that the placement is different. Value is the same. Whenever you compute, it will be the same. Understood? Similarly, in this case, A is there, number is there, yes, number is there. A is there, there. B is there. Okay, now, these are like terms. Let's say I put up ABC together out here. Let's say this. Would this be a like term? Again, most of you say, no, sir. Why? Because there is no number. Sorry. You will be wrong. Again, as I've told you, if you just write ABC, it is understood that it is one ABC. Numerical coefficient is there, there. A is there, B is there, or CBA, ACB. Okay, so just don't get confused. Okay, you just have to see the numerical coefficient, then you have to see, I'm using these words, terms like numerical coefficient, literal coefficient, just to get used to it. I can simply say numbers and alphabet, sorry. Let's talk algebra. When you're doing it, like if you go to Paris, you need to speak French. If you go to Sudan, you need to speak Sudanese. If you go to Egypt, you need to speak Egyptian. So when you are in algebra, let's speak algebra, right? The language of algebra. So you need to concentrate on the numerical coefficients, then you need to concentrate on the literal coefficients. And if all of them are there, if it suits the parameters, if all of them are present, then it is a like term. Okay. Now, unlike terms, what is the opposite of good, bad? What is the opposite of day, night? So the opposite of like terms will be unlike terms. Okay. Unlike terms is very simple, nothing much to explain out there. Those who have different literal factors. Okay. Numbers, again, please don't concentrate too much on the numerical coefficient. You need to concentrate on the literal. Okay, that is alphabets. Okay. Now let me go by the book only. Consider the following examples: 5A and 2B. And 2B. Numbers are there, that doesn't matter. Literal coefficients, no, doesn't matter. One is A, one is B. Sorry. Unlike terms. Unlike terms. Okay. 2m square. Okay, now look, this is interesting. 2m square and 7m. And 7m. Look at what the book says. The literal factors are m squared into m squared and m in 7m, which are different. True. What is m squared? M squared 2 into m into m. Okay. But out here there's only one m. There are not two m's. Though they are though it's square. So you have to be very careful. I'm telling you, you have to just concentrate on the numerical part of the terms and numerical coefficient and the, let's say, numerical coefficient and literal coefficient. Let's concentrate on, they have to be same. Even if, so in this case, confusing, 2m squared and 7m, mm is there, but see the numbers. If you expand this way, 2 into m into n, right? And this is just 7 into n. 1, 2, doesn't make, it's totally different. Okay, now look at the third one, 5a square b and 8ab square. This is again the interesting one. 5a square b and 8ab square. Right? See, they are not like terms. Yes, numerical coefficient is there. Literal coefficients are there. But they are not, they are unlike terms, both of them. Unlike terms. Why? A square and A, sorry, they are not the same. B and B square, as I've already told you in the previous example of M and M square, they are not the same. They are unlike terms. Okay. So the literal factors are A square, B and AB square respectively, and they have difference. Therefore, the above examples represent unlike terms. Okay, I think this should be much more clearer for you. Okay. How many minutes, man? Right? Okay. I wanted to do more, go more. Okay, children, now I will be continuing the rest. Now we have to go through types of algebraic expression: single monomial, 2 binomial, 3 trinomial, more than 3 polynomial. Actually, more than 2 is also called polynomial. Okay, so we'll be doing degree. All these things I'll be following up on WhatsApp. Right? Explanation videos, all these things will be there, and we'll be doing exercise 9A. Thank you, children. मेरा ऑडियो फिजिक्स का कर दूं